This exercise requires students to select an appropriate vertical scale and graph type to plot real-world data. In this exercise, students are asked to graph the number of bacteria observed from 0 minutes to 300 minutes. They have seen in a video that at t=0 minutes there are 2 bacteria, and they've been told that the number of bacteria double every 20 minutes. The graph that they've been provided has the horizontal axis given along with a scale, and the students need to find an appropriate vertical scale to plot the data. One way that they could do this is to complete a table so that they can see how many bacteria to expect from 0 minutes to 300 minutes. This table represents the number of bacteria predicted over time using the doubling model. You can see that for every increase of 20 minutes, the number of bacteria doubles until we reach a time of 300 minutes, and the bacteria is equal to slightly over 65,000. Looking at the vertical scale of our graph, we can see that there are 10 vertical increments, and it's important that we choose a scale that maximizes the space we use on the graph while encompassing all of the data points. It is also helpful to use a friendly number to determine the increment, as it makes the graph easier to read and to plot points. An appropriate increment here would be 10,000 bacteria per incremental marking, so we could label our vertical axis something like this, where our maximum number is 100,000. After we've determined the appropriate scale, we can plot the points on the graph. And as I plot these, you can see that initially the points are very close to the x-axis because the number of bacteria is much smaller than 10,000, which is our scale. But as time proceeds, you can see that the rate of change increases over time until we reach 300 minutes and slightly over 65,000 bacteria. Besides the scale, one other thing that it would be important to point out to students is that this graph, which has isolated points, is appropriate given the context. We're dealing with the number of bacteria over time, and we don't expect to see a fractional number. So drawing a curve through these points would not be accurate, reflecting the number of bacteria seen over time.